All right, so this is the video where we're going to actually do just a little bit of content on this first day here. So all those things listed next to day one up there, you hopefully have done most of them. So we explored the Schoology course page together. Hopefully you've now signed up for Edpuzzle and Delta Math. And you at least know where the calculator link is to register your calculator number, so make sure you do that. And the way you do that, and it's right in the in the Google form, but you do home54 and then about, and that gives you your calculator number. So we've already talked about all that stuff. There's no math like problems you have to do for homework. Probably the only thing that if you're watching this you still need to do is register your calculator number. Okay, so if you have your packet already, so the Cohort C people, you can turn to packet page 1. For those of you that do not have your packet yet, the Cohort A people, you'll be getting it on Monday, you can just do these couple problems on a separate sheet of paper. We're going to do 5 problems, so it won't take up much space. You can just put it on one separate sheet of paper. So you should have learned in algebra how to solve quadratic equations. So we're going to review a couple of the ways of doing that. A quadratic equation is one that has a squared raised to the second as the highest power, and we always want to get those equal to 0. First case that you always want to try and look for is a GCF case. So an example of a GCF case would be, like, say you have x squared plus 2x equals 0. Because there's no constant, we could just take out a GCF, a greatest common factor, and you'd have x times x plus 2 equals 0. And you'd set those each equal to 0 and solve. So that's an example of a GCF case. Difference of two perfect squares, that would be if you have like x squared minus 25 equals 0. And that factors into x plus 5 and x minus 5. And then we would go from there and solve it. Factoring a trinomial, those are our most common ones when you see something with 3 terms, and we're going to see a bunch of those, so we'll wait to show you an example for that. Now, if those 3 things didn't work, those types of factoring, we could do the quadratic formula, the x equals negative b plus minus square root of b squared minus 4ac all over 2a. And then you could also do completing the square. We won't see a ton of 4 and 5 this year. We might work them in a little bit. But we'll see them again in Algebra 2 when you take that. So our first one, we're going to try and solve each of these by factoring. So when you factor, if you have a 1 as the leading coefficient, that means a 1 in front of the term with the biggest exponent. We want to write it in standard form of a quadratic, meaning biggest exponent first, the next biggest, and working your way down. So this is already in standard form, and we've got it on one side, so it's equal to 0. So we would do 2 sets of parentheses. The only way to get x squared is x and x. And then we want to add to this value and multiply to that value. So we want to add to a negative 8 and multiply to a 15. Well, the only way to multiply to a positive is to have the same sign, so both positive or both negative. But the only way you get those you can add to a negative is if they're both negative. So our options we could have negative 1 and negative 15, or we could have negative 3 and negative 5. And we want to know which of those would add then to the negative 8. So hopefully you can recognize it's the negative 3 and the negative 5. We set those each equal to 0, and then we work to get x by itself. So we'd get x equals 3 as one answer, and we get x equals 5 as the other answer. Now, one thing you can do if you struggle with coming up with that little riddle of multiplies and adds to. There's a thing you can do in a graphs page on the calculator that can help you out. So here, we were looking to multiply to 15 and add to negative 8. So we can go to a graphs page on the calculator, and we can do the number we want to multiply to divided by x. So our number we want to multiply to is 15. So we'll be able to do 15 divided by x in a graphs page, and then we can look at the table. So as soon as this calculator pops up, we'll show you how to do that. So we're going to go to a graphs page. So we'll do the number we wanted to multiply to, 15 divided by x, and hit enter. And then you can do Control T to get the table. And all the pairs of numbers that you see here for the x's and y's are what multiply to 15. You just need to find a pair that adds to -8. And you can just look at the pairs of integers. Well, 1 and 15, they don't add to a negative. 3 and 5 don't add to a negative. But if we go the other direction, look, there's -3 and -5. So it takes away one thing that you have to think about, and you can just look for the ones that add to what you're looking for then. All right, the second one here, it only has two terms, and actually I just showed this as an example a second ago, but we can still think of it the same way. We want to multiply to -5, but because there's no middle term, think of it as we want to add to 0. So we're trying to think of two numbers that multiply to -25 but add to 0. And it was kind of a spoiler alert on the previous page, but it's -5 and 5. Those multiply to -25 and add to 0. We'll set those each equal to 0 to solve. And when you solve for x, we get 5 and -5 for those. And what we're really finding by setting the graph equal to 0 is we're saying, when is the y value 0? Well, on a graph, the y value is 0 when you're on the x-axis. So these are really telling us the x values when the graph of it will cross the y or cross the x-axis. And those are sometimes called the roots, they're sometimes called the zeros, and they're also sometimes called the x-intercepts. All right, so on to page 2 for those of you that have the packet, or you can just copy this down if you don't have the packet yet. If you don't have 1 in front of your x squared, see if you can take out a greatest common factor. We can take a 3 out of each of these. So taking 3 out of x squared, and by taking out I mean dividing them each by 3, we get just x squared. Dividing that middle one by 3, we get -4x. And pulling out a 3 there, we get -5. And then we still have to keep the 3 out front, but we can then see what they factor into. So we again want to multiply to the constant value. A constant is something that has no variables, and we want to add to what's in front of the x. So multiply to -5 and add to -4. We would need one positive and one negative. We would need the bigger thing to be negative because it's adding to a negative. And 5 only has one set of factors because it's prime, so it must have to be -5 and +1. Now when we go to set things equal to 0, we only care about things that have x in it. So we don't have to set the 3 equal to 0. If it had been 3x, then we would have to set it equal to 0. Getting the x's alone, we get that -1 and +5 are where x would equal 0. So in other words, if we looked at the graph, we would see the graph cross the x-axis at x equals -1 and x equals 5. So those first three were generous in that they already had the equation equal to 0 and were in standard form. The fourth one here does not have that. So we've got to subtract the 2x over, and we're going to rewrite it so it's in standard form with the biggest exponent. Oops, actually, we have like terms there. So 9x minus 2x would give us 7x. And this is now a greatest common factor case because there's no constant value. There's no number at the end without a variable. So we can pull the x out, and we're left with x plus 7 equals 0. We're going to set each of those equal to 0. We set the thing out front equal to 0 in this case because it had an x. So that's just one answer. Subtract the 7, and you get x equals -7. So again, those are the two spots where the graph will cross the x-axis. So one last one as a refresher of things that you did from last year. We've got a quadratic because we have an x squared. We want to get everything over on the same side. We like our x squared to be positive, so we'll get everything over to the left. So we can add the 6x over. That'll give us minus 3x equals 6. Now, as you're practicing, try and do things without a calculator on homework and in class. On a test, obviously, if you want to punch it in just to make sure you're correct, you can do that. But in low risk settings, like where you're not being graded in class, on homework, try doing it without a calculator. We can subtract the 6 over. Now this is another case where we want to try and pull something out. We can take the 3 out again. If we divide them each by 3, we get x squared minus x and minus 2. And then we need to multiply to negative 2 and add to negative 1. Well, it's nice that 2 is prime. The bigger one has to be negative, so we'll have negative 2 and plus 1. We'll set those each equal to 0. And we'll solve for x. And those are our values of x when y is 0. They can be considered the roots of the function. They could be considered the zeros, they're sometimes called. And on a graph, you would see it as where it's crossing the x-axis. All right, so that's it for what you have to do today. Okay, this video and the introductory one that you watched hopefully before. And we'll see everyone either in class or following along live on Monday.